there's something we forgot to talk about, which is very famous, that we'll talk about now, called the squeeze what? Theorem. Okay? Now, I'm just going to say a few things here about it first. Well, okay, no, I'll give you the squeeze theorem first, okay? The squeeze theorem, as written maybe in your book, right? It starts off with a criteria. You got three functions, and they'll say if, and I always, this kind of drives me crazy. I'm not sure what your book says, but I'll do it this way. All right, whatever, I'll do it the way I think the book does it that way. I don't like it, but okay. You're going to see what I'm talking about. So you're going to have this criteria for x near a. Which is also called, quote unquote, what? Close to what? A. Okay? Now the important detail here for you is to know they're saying here's a function f. Here's g, and maybe here's an h function. Okay? So you really have a smaller function, small, middle, and what? Large. Okay, for values of x near a. Now, the classic picture of that looks like this. Right, here's a. Right, maybe I'll say here's going to be what? Here's that f function. Here's going to be what? G. Okay, and then here's, let me try to do this. Here's the other. And it doesn't matter if it overlaps. Okay? Because being near, being close is really, this is what they mean, being arbitrarily close. Okay? This is what they mean by for values of x close to a. And if you said to me, whenever I see this close to a business, are they saying this limit x goes to a? Yes. X goes to a. So if you have this, then this is what we can say. The limit x goes to a for f. Oh, it's not then, it's and. And the limit of the smaller function equals the limit of the what? Larger function. I think the larger function is called h. Okay? And, you know, it exists. It's finite, meaning we just mean that that limit it's a finite limit. And that's how. Here's that L value. Okay? This is actually the picture, and this is the statement. It's the limit of the smaller function, and the limit of the larger function is L. It's finite. Okay? And that's around that value A. So if you have that, then this is what it means. Then the limit as x goes to a of the middle function. What's the middle function? G is also L. Okay? So let me color coordinate this as if this is, here's G, I guess, and here's what? F, and then here's what? H. Here's that blue as Al. Then there you have it. This is called the what? Squeeze theorem. Now, there's a classic example that exists, and I'm not sure if, because I'm not looking at your book, but here's kind of a classic example, I should say. They want you to look at the limit as x goes to 0, maybe of x squared sine of x. Okay, I'm not sure if that's what the book is saying. Maybe. This is a very classic setting here. Right, so, I mean, do we have Desmos up? Let's get Desmos, right? Share with you guys here, Desmos. I don't know how, I like Desmos. Y equals, let's go to Desmos. Share with you guys x squared. And I don't like that, I don't like my graphs in red. I like to use it for something else. Very classic. Oops, not sine. All right. And let's change that color. And this is around what again? Around 0. So obviously this is a nice, beautiful, continuous function. Is it continuous? Yeah, it's a nice, amazing function. What do you guys think? So around 0, the limit's going to be 0 graphically, right? Function's continuous at 0 anyway. Oh, I think I made a mistake. Yeah, I apologize. Made a mistake. Let's go back. This is 1 over x. Okay? So I'm going to change that to 1 over x. Let's actually change this to 1 over x. Now, there we go. Let's get closer and closer to 0. So you're going to Mr. Judge, this is behaving in a way that's, wow. All right. Now that's a lot better to work with because the other one, because it was nice and continuous, we just plug in the value and all is well. Right? You guys understand what I'm saying? So let me go back here. So you're going to look at this and you go, how do I answer this question? I can't plug in, my x value because it's nice and continuous and I get the value of the function. This is kind of interesting. So how do I show that the limit is 0? And sometimes they'll say, show the limit is 0, right? I've seen books write this down. Show the limit as x goes to 0 of x squared sine of 1 over x equals 0. They can even say that, right? All right, now here's what you're supposed to do. Now, this is a classic question, and what I mean by that is the following, okay? It's classic, meaning, you see this statement here, sine of 1 over x? Let's give you guys this fact. Do you guys know the absolute value of sine of any angle is less than or equal to 1, okay? This is an extremely important fact about the sine function, right? And so what that means is that -1 is less than or equal to what? Sine, which is less or equal to +1, and this is for all theta. Okay, you guys with me on this here? All right, easy peasy lemon squeezy, so far so good. All right, and then now what I'm going to do here is this, so you guys can see this, is I'm going to take that x squared term, and I'm going to multiply the left, the middle, and the right by what? x squared. And what do you end up with? This is going to be what? Negative x squared less than or equal to x squared sine of any theta value, which is less than or equal to x squared. Now, in this case, we're also going to let that theta be what? Okay? This is your 1 over x. So it's sine of anything. Okay, so what you're really looking at now is going to be this. Negative x squared less than or equal to x squared sine 1 over x less than or equal to x squared. So what you have now, let's go back to our colors. Green and, what is it? Green, orange, and gray. Green, orange, and gray. So far, so good? All right. Did you guys see what I'm saying? This is the what? This is your smaller function. This is the what? The middle. And then this is the what? Large. So now, here's what you know. Isn't it true the limit as x goes to 0 of x squared is equal to the limit as x goes to 0 of a minus x squared? And they both equal, what do they equal? Well, I don't know. Let's note by direct sub. Isn't this going to be 0 squared, which is really 0? By direct sub. Right? Isn't this going to be negative 0 squared, which is also what? 0? Is that true? So they're both equal to what? 0. And that's that finite value. They're saying what? Al in the squeeze theorem. This is that limit value, al in the squeeze theorem. So they're both equal to what? 0 in the squeeze theorem here. So what does that conclude about that middle function?
0.
The middle function is also 0.
Yeah.
That's why that's called squeeze theorem.
Like in between.
Yeah, right, in between. So you can say, oh, that limit, x goes to 0, x squared sine 1 over x equals what? 0. But you also want to say this, ladies and gentlemen. You want to say the following. This is extremely important as well. You can say by the what? Squeeze what? Theorem. So this is going to be a pretty big deal. This is a big, big deal. And I have to go into a little bit of details here for you guys. Why do you think they might have chosen the x squared? You know, because what they can do, and I think your book might even have something like this. They'll give you another example of this here. If you guys want to know the truth, they can say, what about the limit as x goes to 0 of x to the 4th now cosine, 1 over x squared? It's a very similar question here, right? The process is exactly the same for the exact same reasons. Now you might say, why? Well, this here, what do you know about cosine as well? We're gonna write it this way too here. We're gonna give you guys another note or a fact, right? The absolute value of cosine of any angle is less than or equal to 1, which is the same as saying negative 1 cosine less than or equal to positive 1. That's what they're saying. So in this case, you can say, does this mean, the following? The answer is yes. That's in purple. Is that x to the fourth? Why do you think they use x to the fourth here, like over here they use x squared? There's a very good reason. It has to do with inequalities. What do you guys know about inequalities? If an inequality is ever negative, right? Or if you multiply by a negative number, what does it do to your inequality? Do you guys know? Well, it changes it. It changes it. But if the number is positive, what's the story? Doesn't change the direction of your inequalities, okay? So this is why they use x squared and x to the fourth. They can use x to the sixth because what you can now say is this. You can say this is negative what? X to the fourth less than or equal to x to the fourth cosine 1 over x, which is less than or equal to x to the what? Fourth power. It does not change the direction of your inequality signs. That's the whole idea. You're saying this here, right? It won't change that direction. This is why they need that power there to be an even power. You know, it's kind of a thing, just so you guys know. Anyway, when I see this in my mind, I go, oh yeah, I see what they're doing. Okay. Now what's going on? You want you to take the limit of what? The smaller function, which is the same as the limit of the what? Larger function. They're both 0. Is that true? Now you say, why? Just in case, you might say, I don't even know why, Mr. Judge. Well, plug in 0 there. That's negative 0 to the fourth, which is what? 0. What's this? Limit. X is 0 of positive. And that's going to be 0 to the fourth, which is also what? 0. And then, what are you free to say now, ladies and gentlemen? What are you free to say now? Yeah, by you can say the limit, now the middle function. That's the middle function. Where is it? Limit of that middle function. X goes to 0. X to the fourth cosine 1 over x is 0 by the what? Squeeze theorem. Yeah.
Do we have to write the pilot squeeze?
Yeah.
Theorem, like during our test or something?
Yeah, because you want to know why. They may say, why is that? Because they want you to show that this limit equals what? 0.
Also, we must mention that.
Yeah.
Okay.
By squeeze theorem. Okay, now you go, okay, Mr. Judge, does it always happen that way? And I'll say to you, well, no. If I look at that study guide, let me go back to the study guide, okay? Let me briefly look at that. Because when what I did was I looked at some of my notes and some stuff, some past tests, and I go, oh, yeah. Take a look. Oh, don't look at number 31. Don't look at 32. Maybe number... Can't even see. Number 34. So I'll give you guys another example. It's similar to an example in your book. Okay? It's similar. So I have what? Negative 6x plus 5. Now I'm going to change this is what I mean. You say, Mr. Judge, this is now f. I know. So they're defining the function over the interval negative 2 to positive 2, okay? And now they want to find the limit as x goes to 1 of the function. So let me share with you guys. This is kind of nice, neat, and simple, okay? All right, let's go over all those details. Because there's some kind of in your book that way too. Squeeze theorem kind of questions, you know. Did you guys notice that? Did you guys see that? You go, hey, when's that Mr. Judge going to talk about the squeeze theorem, right? When's that guy? Well, here's what's going to, and again, I think I don't know, whatever I use. I'm going to use, God, it changes. Okay, green and orange and gray. So maybe it helps you see. This is the smaller function. This is the middle function. And then this is the what? Larger function. Okay? Now you say why? Because of those inequalities. You guys see the less than or equal, less than or equal? So this is the smaller. This is the what? Middle. And then this is the what? Larger. And they're saying it's good over this particular interval right here for these values of x. Now, what do you guys know if they say x goes to 1? Isn't 1 in that interval from -2 to 2? So this is what I mean by, for x around 1. So they're saying, hey, you have this situation. All right. And find the limit of the what? Of that middle function. Find that limit of that middle function. So here's what we say. What's the limit as x goes to 1 of that -6x plus 5? Do you guys know what that limit is? What could you do? What do you guys know about this function, -6x plus 5? It's a nice what? Polynomial function. It's nice and continuous. Oh my God, direct sub. Do we get a finite number as I plug in my number? Yeah, -6 plus 5. What do you get? You go, my God, that's -1. All right. Okay. So that's the limit of the what? Of the smaller function. All right. Now let's find the limit of the larger function. You go, what's that limit of the larger function? Okay, here's the limit of the larger function. You say, isn't this, again, what do you guys know about x squared minus 2? That's a nice what again? Polynomial. It's actually a quadratic, but quadratics are polynomials. Hey, do you guys remember, since I'm using that language, what's a polynomial anyway? What are those things? And this what? P of x is what? A(n) x to the n plus a(n) minus 1 x to the n minus 1 a1x plus what? A0. Where are the constants? You go, what are the constants here? Okay, I guess we'll use pink. Those are thought of as constants. So anything that looks like this, any polynomial function, what do you guys know, is nice and what? Continuous. It's continuous everywhere. What do I mean by everywhere?
So everywhere.
All real numbers. That's what they mean. All real numbers. They mean by everywhere over the real number line, okay? From -infinity to +infinity. So you might say, why are you actually mentioning this to me? Because remember the definition of being continuous at a point? What is a definition? The limit as x goes to a of any function is simply what? Direct substitution. It's direct substitution, ladies and gentlemen. This is what that means to be continuous. So if you're continuous for any real number, that means in particular you're continuous at a. Just plug it in. That is what it means. So the left side definition, you're looking at a limit, and it equals f of a. So you go, okay, is that why you're plugging in what? 1 And you get a nice finite answer, yes. 1 minus 2 is going to be what? -1. So I'm giving you guys all the gory detail. What do you guys notice about this? They're both what? -1. They're both the same. So the larger function, the smaller function, and the larger function have the same limit. What does that mean about the middle function? It's the same. It's -1. But you want to say this because they're going to say show. Listen, in mathematics, we're very strict. What that means, you want to cite. Why? By the what? Squeeze theorem. What do you guys think? Let's look at the book. Let's get one. My God, calculus is so easy. What do you guys think? So easy. Oh my God.
Getting harder.
Is it getting harder? You know, it's kind of interesting. I always say this kind of stuff, you know. How do I put it? Let's think. You know, I'm going to be sitting on this committee. It's a statewide committee. It's called Intersegmental Committee of the Academic Senates. It's when the higher ed systems, the CCCs, community colleges, CSUs, and UCs, we meet together. The math discipline, we meet together. Now we get together. We're going to talk about, you know, math education, meaning what math skills high school students should need to take higher ed, you know, to go into STEM and math, you know, really STEM and math's part of STEM. It's the M in STEM. You know, what math skills. And you know what's interesting? You know, guys, you want to know what the truth it always comes down to? Here's what I've been saying my whole life, 20 years. If you know arithmetic, I can teach you algebra. Let's say that again. Knowledge of arithmetic leads to knowledge of what? Algebra. Without arithmetic, you can't learn algebra. It's like saying, if you're going to walk, you first crawl. Okay. I can teach you calculus if you know what? Algebra. So hence, you say, what does that even mean? What do you think the biggest issue that people have in calculus is? Algebra. I should just write that paper now, put those two statements, and I'm done. All right? That's it. Over. Done. It's not rocket science. So when people say, oh, it's going to get harder, it's really code for saying what? You can do some algebra. When I teach like a Calculus 2 course, I love that. You guys know why? Because I get to tell the Calculus 2 students, you know what I get to do in this class? What? I only teach you what's new. What I teach is 10% new, 90% old. Like, what? What are you talking about, right? What is Calculus 2? Well, you got to know Calculus 1. You got to know some trig, pre-calculus, and then, you know, the rest is kind of new. So in other words, I always say to the Calculus 2 students, hey, if you're having trouble with Calculus 2, it's all about your past. Your past is coming back to haunt you. It's really what it is, you know. Something similar to Calculus 1, although Calculus 1, I think, is a little difficult in the sense that you're learning something new, in the sense a limit is an approach. You guys know what I mean? A limit's an approach. The value of the function is at that point, and then you see the different settings. That's new. You may not even realize, you know, piecewise functions for absolute value, you know. something new like the squeeze theorem, smaller, middle, larger, and the little details here that they give you that I try to inform you of. And some of the algebra is kind of new algebra in a way. I can share with you guys what I mean coming up. You guys will see that. But it's an algebra thing, and that's all. But if you have algebra skills, then you can focus on the what? On the process, and you're good. It's easy.
So math is easy.
If you have a strong foundation. Ooh, I'm going to say that again. It's preaching time. If you have a strong foundation, it's easy. If the foundation isn't strong, then you have to shore up the foundation as you go along. All right? And that's kind of what it is. Sure. That's the deal. So, you're not alone. And I was a student. I had to work on my arithmetic and algebra students when I took calculus. I had to work on all that. In fact, I'm going to tell you guys the truth because the truth sets you free. My trig instructor at ELAC, it was at ELAC. I took trig at night. I'm going to tell you guys the truth. This is why I get in trouble. Some people love me. Some people hate me. You know why? Because I tell the truth. That's going to happen. I was taking trig at night, and unfortunately, my trig instructor was crazy. And I know you guys say, oh, your math instructors are crazy. No, that's not true. But this guy was really crazy. He lost his marbles. So we'd come in to lecture. He'd have the lights off, kind of like partly this way. Wait a minute. He'd have the lights off. I have it off for the projector. He had no projector. This is a chalkboard. The lights are off. And we're supposed to learn trig. He forgot trig. So he would stand in front of the podium with his trig book reading it as we're sitting there watching him. And he's scratching his head. He lost his marbles. It happens. So we're all looking at each other. What do we do? And I think somebody raised their hand. Do you mind if we read our books? See, back then we used to buy the books and read them. It's not done so much anymore. Well, I would read. I go, can we read the book then? Yeah, hey, yeah, go ahead, read it. So we started to try to teach trig to each other, reading. He literally, and then eventually they removed them. Back then they didn't check prerequisites, so we all went to the next course. It didn't matter what grade you got. Kind of like today, that's what's going on. But what I'm saying to you is I understand what it means to have to learn material as you go through the process. And I'm going to even boldly say to you, get used to it. Get used to it, because I've had to review every step of the way for every class I ever took. I've had to review, so get used to it. Now, you can either embrace it, you feel sorry for yourself and get mad and all these things. I work with a bunch of negative people, and I have to shut my door sometimes. And I don't want to be around it. But you got to make a choice with how you're going to look at your situation. If it means you got to review, you review. No big deal. If you want to feel bad and complain, well, you could go that route. But you know what? Nothing's ever solved that way. Trust me on that. You might as well put the energy in doing what? Reviewing your algebra or your trig or whatever it is. The good news is I have a whole bunch of videos and resources there for you that help you review. I never had that. We had to read it on our own. We had to read the book if you wanted to review. So, you guys have that. That's a benefit. But anyway, that's the truth. All right? So, not a big deal. So you said, what was the hard part of what I did for this question? I mean, I used the fact, but I plugged in the number and I did arithmetic. You guys see? Arithmetic skills. I was lucky. When I left high school, I had arithmetic skills. When I left, that was the one thing I definitely knew. I barely got out of beginning algebra in high school. Algebra 1. Because I never did my homework, never studied. It wasn't until I came here as a student that I started studying every day. I did my homework every day, and my life changed. Just because I did my homework. My whole life changed. Doing homework. I don't know. So I'm going to say to you guys, too, your life can change, too, if you did your homework how? Every day. My life changed. So I had to review my algebra. I had to review arithmetic. And back then, they didn't let you use calculators. So you really had to do your arithmetic. I did some arithmetic with trig earlier. They're looking at me like I'm crazy. 3 times 60 degrees is 180. Get out your algorithm, 3 times 60. They're like, no. Can I use my calculator? And I'm like, oh my God. You can do this. Review your what? Arithmetic. That's how you get stronger. And then you're going to get good at arithmetic. That's what happened to me. I got better. Doing homework every day. Where's the squeeze theorem? Is it 2-2 or 2-3? It might be 2-3. All right. Does that sound kind of interesting, ladies and gentlemen? Should be. Let's get a squeeze theorem question from the book, just for fun, to share with you guys all these details. All right. Okay, so they're going to say to you, here's 3x. I think I gave you guys the odds, so I'll do an even. Here's my function. Less than or equal to what? X squared plus 2. And that's going to be for what? 0 less than or equal to x less than or equal to 2. They want you to evaluate the limit. Hey, is this the same question? As x goes to 1 of f. It looks very similar. I might have looked at this question and changed it around to create my question. That's what I do sometimes. I look at your book questions, homework, and create a similar one. Because I don't want to take the fun away, All right. All right, what do you guys notice? I forgot even the colors. Where are we at? Green, orange, and gray. Green. What's this? Orange and gray. So you're getting the smaller, middle, and larger. They're going to ask you the limit for the middle function. That's a tip-off, ladies and gentlemen, at squeeze theorem. When you read these kind of things, they didn't tell you, hey, use squeeze theorem. I don't think it says that. But the tip-off is when they give you that kind of criteria. Small, middle, larger. Okay? Small, middle, what? Larger. Okay. Let's be in the middle here. Limit. X goes to 1, 3x. That's 3 times 1. Why can I do that? Well, a linear function's a polynomial. It's continuous. I can do direct sub. What is 3 times 1? 3. Okay, that's a nice finite number, right? All right, what about this? Limit. X goes to 1. X squared plus 2. A nice polynomial like before. It's continuous everywhere. It's continuous at 1. And I can do my arithmetic. What's 1 plus 2? 3. Okay? Look at that. It's a process that involved arithmetic. Nice. No big deal. Hey, but you want to know something? That's the limit of what? Smaller function and the what? Larger function. What does that mean? The middle is the same. These problems are specially chosen, ladies and gentlemen. They're specially chosen. They're specially chosen so that when you use the squeeze theorem, it works out that way. So this is going to be 3 by what? Squeeze theorem. Easy peasy, lemon what? Squeezy. Squeeze theorem. And that's pretty much it, ladies and gentlemen, for squeeze theorem. Not a big deal. But I got to warn you guys, sometimes students love squeeze theorem so much, they want to use it on everything. And I'm going to tell you, don't go there. You can't. In theory, if you have all of this, then yes, it applies in theory. but all the homework questions on it are very specially chosen. You're not going to be able to, come up with a small function and a large function, generally speaking, that this happens for and find limits. I think it's kind of like they kind of want to notify you about this very special and powerful theorem, but it's highly what? It's highly where they have to give you, they set it up for you very nicely. And you say, well, how can I recognize it? You have multiples of sines and cosines. And that first term is going to be always a positive number, like the red. I mean, they can even change that to this. Like, they can say, okay, square root of x. You go, is the square root of x always positive? So I can even change it on a test and give you the square root of x, sine 1 over x. When you go down here and you multiply, by square root of x now, that's always positive. It doesn't change the direction of the inequality. That's really why it works. Anyway. And then let's get to a definition here, ladies and gentlemen. I don't think I'm going to draw the picture, but let me double check on my website really quick here. I want to see which one I want to start with. Well, okay. Let's try something like this. Alrighty.